All right. So today we are going to talk about the TCP IP Attack Lab. Um, this will be your homework 5, and as I discussed on the class, you will have 10 days to finish it. But before before you start this lab, I will first demo it for you. And yeah, also this lab is closely related to our what we introduced in our class, so that I think it's necessary to demo it for you. Mm, for this lab, as it mentions, the learning objective of this lab is to understand the attack against these vulnerabilities. And for the TCP IP part, you are going to this lab will cover the following topics: uh, the the TCP protocol, the synchronized flow attack, and the synchronized cookies, the TCP reset attack, and the TCP session hijacking attack. At last, you will try the reverse shell, which we did in the buffer overflow attack. So a special type of TCP attack. For this one, we will skip it. And for this lab, firstly is about some environment container environment setup, and I will show you. So after you downloaded the lab in the lab setup, you can let me first turn off my previous containers so that they will not influence our results. Let me see, DC down. I will use DC down to stop previous containers. And okay, it's done. So now we will start it. So we can use DC up. Before this, you need to use DC build to build the container, and then use DC up to start them. So in this lab there will be 4 containers. The victim, the one is the attacker, second is the victim, and the third and fourth are users. In fact, we will only use the user one. So now here we start the first one. We use doc ps to show all the dockers and their ID, and then use a doc sh to get into the attacker. The attacker is 7D, so this is the attacker's container, and then I need 2 victims. Still, let me see. So first victim will be the 10.9.0.5 docker sh04. So this will be the first victims container. If we use fconfig, it is this IP address. And we also need another container, another user. So dog sh. We will use the 6, the IP address ends with 6. It is FB, and let me let's check it. So this will be this IP address. And for the attacker, the IP address, in fact, it is we will use this address 10.9.0.1. So in our code we will use this IP address. So now we have 3 containers: the attacker, 1 attacker, and the 2 victims. And now we will start our task. Our first task is a synchronized flooding attack. So which is a denial of service attack, and the attackers will send many synchronized requests to the victim's TCP port, but they have no intention to finish the three-way handshake procedure. So attacker will use some proof spoofed IP address and yeah, this figure shows how the synchronized flooding attack work. And in this attack, we need to know some before this attack, we need to know some knowledge. One is the size of the queue. Because for the synchronized flooding attack, our aim is to occupy all the queue, and so that the new requests will could not be accepted by the server. So that we can use this line to this command to get the queue size of the current server. So let's try to do this. So you can see that now the max synchronized queue is 128. And we can also use this command, the net state minor net, to check the usage of the queue. So for the server, if we try to do this, we will find that there are already some connection there are already some ports listening to some upcoming packets. And so this is for the queue size. And we also in our task we also need to turn off the cookie countermeasures. So by default there are some Ovanto's countermeasures it is turned on. And it is about the synchronous cookie. We will turn on it later, but now we need to turn off it. So for this one, we will check it in the victim's server, victim's machine. So this is a victim, and if we check it, we can find that because this is seed lab, so that they already turned off the synchronized cookie setting, so that in the victim it is already turned off. And later we will turn on it using this command. We will use this to turn on it. So our first task is to launch the attack using the Python. So so in the lab, they already provide such a Python code as shown in this document. And in this document, in the code, you need to fill in some parts. One is the destination, the IP destination, which is the packet you are going to send to, and another one is a destination port. So you also need to get to get this information. And and in this code, we also import some libraries to generate some random IP addresses. So these libraries, and they are used here. So in our packet, we will set up the IP, the source IP as a random IP address with 32 bits. So that in fact is a spoofed IP. And for the TCP port, we will also generate a random 16-bit port. For the sequence number, we know it's important. We also will generate a random number. And then after that we send this packet to the victim, and we will keep sending it so that it could perform the synchronized flooding attack. So this is a code showing this in their lab. And so in our let me show you here. So so here is the code that I already filled in, because I'm going to use the attacker's machine, this machine, to attack the victim's machine, which is this one, so that the destination IP address is 10.9.0.5, which is this IP address. And for the port number, we will use 23. And then for this one, we can let me put it here. And So what we need to do is we first let the attack run for at least 1 minute, so that they are so we ensure that the synchronized flooding attack already use used all the queues in the victim's machine, and then we try to use telnet to log into the victim's machine. And we can do like this. So this is a code, and this is the machine. We put all the things in the volumes folder so that we can get it. So this is the code, and we just run it as 3 dot Python, and then it will go keep sending if packets to this one. And in fact, in this one, we can use the previous we can use this command to check about the network information. And if we check it, you will find that there are lots of synchronized received packets, and they are from random IP addresses. And yeah, so now it is keep sending, the attackers keep sending packets, and for the victim, what we need to do is we need to use another terminal to connect to the victim. So we will use a telnet 10.9.0.5. We try to use it to log in to this victim. And as a result, we can imagine that it doesn't work because all the queues are because all the memories has been used by the synchronized flooding attack, so that it couldn't so that for other machines they could not connect to the victim. So in fact, this is the first this is a task 1.1, and uh, although it is very it seems to be straightforward and simple, but there are some reasons that may lead to your attack fail. So and they provided some reasons. One reason is the TCP cache issue, and they explained more details in the note A. So so in fact, this is because they mentioned that this is because if you use a machine to if you already use one machine to connect to the victim, and then the victim can remember this remember the this machine, so that for the in such case the synchronized flooding attack will not work for the victim. So for example, we use this machine to log into the victim. So now because there's no we stopped the attack so that it could log in. If we log in and then we exit, so that in this in the victim, in fact it knows this machine. Let me see if we can use some yeah, like if we use the ARP, we can find this IP address is stored in this machine. And in such case, if we start the synchronized flooding attack, and then we still use this machine to connect to the victim, you will find that you can always successfully log into this victim, because the victim already remember the machine, this machine. So that's the first possible reason that why your attack doesn't work. And in this node, it is showing in the node A. And what we need to do is we need to use the these two commands. One command is to show the connection between the victim and the user, another user. So if we check it here, we can find that the this machine the user A is in the victim's memory, so that we need to remove it using this command, the flush. So if we use this command and then we show it again, there is nothing, so that the victim doesn't remember this machine. So now the synchronized flooding is still here, and if we use it to connect to the victim, now you will find that our attack is successful because the victim doesn't remember this machine. Yeah, so maybe later I can call the victim as user A and this one as user B so that it will be clear. So yeah, so for the first issue, it is because uh if you already use the user B to connect to user A, so that user A will remember user B. And in such case, the synchronized flooding attack will not work for the connection between user A and B. So this is one possible reason. And the other reasons, there are some other reasons such as VirtualBox. If we are doing the attack for one virtual machine against another one, instead of using container, you may meet some issue. And if you are doing the attack using the container setup, just like what I did using 3 containers, it will not there is no such issue. And some other issues are such as the retransmission issue. So and the size of the queue. So for this tool, you can adjust the transmission number and the size of the queue. You can reduce them so that there is a higher possibility for you to run the attack successfully. And yeah, that's for the task 1.1. And the task 1.2 is we are going to launch the attack using C. So because the C program is pretty complex, so that they already provided the code for us, and you don't need to change anything. It is synchronized flooding .c. And in this code, we can see that we will define something in the main function, and we will define the TCP, the source port, the destination port, the sequence number and flags, and this is for the TCP part. For the IP header, we also need to fill in something, and yeah, we don't need to change anything for this one, and we just need to for the task 1.2, we just need to use this command to compare it and then run it. So when we run it, we need to provide a target IP address, which is this one under the port number 23, so that I will use this command to do the same thing. So I will stop it. So this is the attacker's machine, and let's use this one to attack the victim's machine. So now let's see the yeah. So there are any synchronized received packages, and if we ping it, still we could not ping we could not connect to the user A. And yeah, so we can you need to compare the results between the C program and the Python program, and in fact they are doing the same thing, but the only difference is for C program it will be much faster, so that it can perform the attack in the short time. So for the task 1.3, we will enable the synchronized cookie mechanism and run the attack again. So let's see where is the command. So here is the command for the turn on the synchronized cookie. So we will turn on it for the user A. We stop the attack, and now it is turned on, and we start attack again. And then for this part, so we try to connect to the using user B to connect to user A, and then now we can see that it is success. we can log in it successfully, means that the attacker doesn't work now. So this is the for the synchronized cookie. And this is task 1.3, and we import the cookie. And yeah, I need to turn off it so that it will not influence our later attack. So this is for the task 1. And for the task 2, we will use the TCP reset attack on the telnet connection. And so here are two parts. So one is launch the attack manually, and another one is automatically. First, we will do the attack manually. So before this, for the user A and user B, we need to build the connection. We will use the telnet 10.9.5 and use a login to the user A. So here the login username is seed and the password is DES, which is in reverse. So that after this, user B is successfully connected to user A. And now the attacker's aim is to break this connection. And here is the code they provided. And in fact, this is the code is very straightforward. So this is for the task 2. So in the code you need to fill in the IP address and the and the port information. For the IP address is straightforward. We have the we know that our connection is between user A and user B, which and their IP address is 10.9.0.6 and 5, so that we just input it, and then we need to build the TCP. For the TCP, we need to know the source machine's port. So this a user B's machine's port and the sequence number. So here in the tutorial, it mentions that we can get them from the Wireshark, but some students may not use may use the terminals on the Amazon AWS or somewhere so that they cannot use Wireshark. So in such case, we can use another way to get these two information. So we can use the TCP DUMP, which is a command to capture the network traffic. And then because we already have the connection, so that in the user B, in the user B, we just input anything, just like some let me stop it again. So now we so what is this? So this is already logged into this, so that they have. So what is this? Big and config. So sorry. Give me a second. All right. Let's continue. So yeah, as I mentioned, if you do not have the Wireshark, you can use a command called TCP DUMP to capture the packet. But I just made a mistake, and in fact, we need to use the -I and any to capture the packets from all interfaces. So if you directly use TCP dump, you will only capture specific type of the interface instead of all. So now let's do like this. So we will use this one to capture any packet, and for the A and B, if we input some information, no matter the any character or anything, we can get some information from the TCP dump, and so for example here this line, we can see that this is packet from the point 6 and to the telnet to the point 5, and this number is the 47370. This in fact is a port number, a destination, the source port number, so that we can get this port number. And for this task, so now we have the port number. It is 47370. And for the destination port, we will keep it. And also the sequence number. Acknowledge. Let me see where the sequence number, or we can find it here. So in the first first line of packet, we can get this information. So we can see here is a sequence and the acknowledge number. So for the sequence number, you can see there are two numbers. So in fact, this is because if we use Wireshark to sorry, not this one. We input anything and everything will be a packet. If we use Wireshark to read it, we can find that in fact there are two sequence number here. One is the sequence number and one is next sequence number. So that is this number and this number. So the first is the sequence number. Second is next sequence number. So we will use the first one. We copy it to our code, and now we can design such a packet. And for this packet, what we want to do, so now we have the connection between user A and user B, and then we try to use the attacker's account to do the attack. So we do the Python 3 task 2 Python. Oh, sorry, not here. CD volumes. Also, I just restarted all the containers, so that now the container number is different with what you in task 1, so that don't mind that. That's not important. So let's see, if we use a Python task 2 Python, it will send a packet to the user B. So from we will send some packet from this IP to this IP, and using this port source port number, and let's see if there is any other sequence number. So we just found this sequence number here, and in fact doesn't work. Okay, stop pausing. Yeah, let's continue. So I did some testing, and I found that in fact for the task 2, for the launching the attack manually, we must need the Wireshark, so that for this task it will not be a mandatory part. So for this part, if you have the Wireshark, you can do this. And if you are using terminal, you can skip it and only doing the second part. And here I can show you how to use Wireshark to do this part. So I just mentioned that we can use the TCP dump to get this information, but for the TCP dump, in fact, the problem is there is no, it couldn't get the sequence number of the closest packet. So for example, there are many packets, and for this one, this is the closest packet, and it couldn't get the sequence number of this one. But in the Wireshark, we can get all the packets number. Oh, sorry, here. So like this is from the 6 user B to user A, and here the sequence number is three. The last three bits is 354. But in the terminal, we can only get the sequence number from this line, and the sequence number is 345. So that this is 345. This in the Wireshark is 354. So that in fact for the TCP dump, it couldn't get the following the sequence number of the following multiple packets. So for this task, if we want to manually do this part, in fact, we need the sequence number of the last packet. So here we can see for the TCP we get the source port number and we need the sequence number. This sorry, this line. This one we copy it and put it here. Then we run it to the Python 3 task 2. And after this, if we go back to the user B, we will find that the connection is closed by the foreign host. This is because our attack, and we send a packet, and this is a reset packet. So where is the reset? So here you can see that the flags is R. So this means it is a reset packet. So this is for the launching the attack manually. So as I mentioned, this will not be a mandatory task. But for after that, we hope to do this part automatically, so that we don't need to manually input the IP address and the sequence number. So so let me see. So here is what we can do to automatically do this part. So we first sniff all the packets on the internet, and in this part, in this command, we need to get the interface of this line. So we can use config from the attacker's machine to get this this face. And we copy it to here. And for the filter, we will use a TCP for this task. And we know that we will have the port, we will use a port 23, so that we put it here. And in this function, we will do the what we will do is, no matter what packet we receive, we will send a reset packet to the source. So if we accept one packet, we will design a new packet, and for the new packet, the destination will be the previous packet packets source IP, and for the new packet, the source will be the previous one's destination. And for the TCP, we still need to set up the flag as a reset packet, and then the sequence number will be the previous packet's acknowledgement number, and the port number is a previous packet's source port number, and all the other things are just in reverse. And then we design such a packet and send it. So for the sequence number, we get it from previous acknowledgement, because in the TCP we know that so such as for this for this packet, when you send it, the sequence number, next sequence number, and acknowledgement will be sent. And for the next reply packet, the sequence number will be the previous packet's acknowledgement, the 192. So for the previous one, the acknowledgement number is 162, and add some number, so that in this task, what we will do is we use the information from the packet that we received, and we can we make such a packet. And so here is the user B, we still try to connect to the user A. So before that, let's run the code task2 auto.python so that it will block all the connections. So for this, you can see that we haven't we once we try to log into the system, this part I will stop. So for the our attack will start to work and block all the connection. So we can do it again. So we run it and we try to use it to connect to it. So when we try to do the connection, it is closed. And in fact, for the for the attacker, it is keep sending packets so that it can block all the things. So yeah, this is for the task 2, and yeah, you can mainly focus on the second part to launch the attack automatically. Okay, next we will go to the task 3, the TCP session hijacking. And for the task 3, our objective is to hijack a TCP connection between two victims by injecting malicious content into this section. In the task 2, what we did is we inject a reset packet so that the connection is disconnected. But in this part, in this task, we will do more things. We will inject some malicious code. And yeah, the figure 3 shows how this works. And so they also provide some code. So for task 3, we will only do the work about the manually. We will only launch the attack manually, and we don't need to launch the attack automatically. We just finish the first part. And different with in addition to the IP and the TCP information in this task, one thing we need to add is about the data. In fact, the data is some command that is going to be executed uh, by the victim. And so in this task, we just do some simple things, just like reading some files. So let's see. So this is user B, and in the user B, I will create a file called uh called oh oh sorry for this one I need to connect to user A, and we first build the connection, and now we can use user B to log into user A, and then we show I created a file here. It is called secret, and you can use this command to in fact to create it. So this is a secret file, and yeah, now it is here, uh and we can also use cat to read it. This is a secret file, and our task is to use the attacker's command in the packet to read this file. And for other things, they are similar with the previous task. We define the IP layer, and then we get we define the source and destination IP, and then we get the TCP information. So in this task, we still need to use the TCP dump to get the sequence number if you don't have the Wireshark. But there is one thing we need to be careful. So if we use this to capture it, and then in the user B we input some information, input some characters, we could get the information. We could get the sequence number from this part. But in the user B, you need to delete what I just input, and if you input one character, you need to delete one. If you input two character, you need to delete two characters. And don't leave them here, and don't delete more than what you input. So I don't know the reason why. This is based on my experiments, and for this task I did lots of times, and I found that there are some you must keep this user B's terminal command as empty, so that it will not influence the following result. So from the TCP dump, we can get the port number, such as the port number is here is 446, 4746, and for the sequence number and the acknowledge number, we just copy it and put them here. And because this terminal will be used to send the packet, so that we need another terminal to keep monitoring and accept the information from the victim. For this one, we will use this command to monitoring and capture the information from victim. So now we will use the attacker's machine to send the packet, and in fact it sent a packet to the victim, the user A, and in the packet it asks user A to execute this command, and this command is to read the information and send it to the attacker's IP. So for the attacker, the IP is 10.9.0.1. So that after if the attack is successful, the victim will send the information to the attacker, and on the attacker's machine you can get a line output, this which is content in the secret file that we created. For this is for the task 3, we just need to read the file and get the information. So this is how to launch the attack manually for task 3. And one thing you need to be careful is about here. When you when you input some character, you need to delete them. And in fact, after this attack for the user B, we will find that the user B's terminal is locked. We cannot input anything else into this machine, so that in such case it means this your attack in fact is successful. So that if we for the task 4, in fact we need to close the terminal and create a new terminal for the task 4. So we need to do the same thing to connect to the user A. Okay, so this is for the task 3. And for the task 4, in fact, the basic idea is same. So but the only difference is we want to create the reverse shell using the TCP session hijacking, so that after the attack, we can get the root privilege of the victim's machine. So this is same with our previous buffer overflow lab. And so what we need to do is we still use one machine to send the malicious packet, and use another machine to keep capturing the package. So yeah, you can see this is the second attacker's machine. I put it here. It will listening on this part, and this is for the attacker's part, and for the attacker, what command we should send? What command we should send? So what we want to send is this command. This is a reverse command, and it is if the victim execute this command, it will if the attacker could get the root privilege and get the control of the victim's machine. So that we want to put this command to the packet, to the data, to the data part, and so here is our example. So for you can see that for the data, we just put them here, and we use this uh, uh, to we also need these two characters to make everything correct. And inside of it, it is a command, and yeah, so I need to change all the IP address and the sequence address, and let me do it. So we do the same thing. Okay. And this is the new port number 474452, and the sequence number, the acknowledge number. Just put them here. And yeah, also the interface. I need to change, I need to get this one to here. And now this packet is finished. And let's see, here we are listening to the this port, and then we try to run the code. 3 that's 4.Python. So yeah, you can see that we send this packet to victim user A, and then user A execute this command, and after this user A will allow the attacker to control his machine. So now we are in the we get the root privilege of the victim, and now we can do everything in his machine. So okay, let's see. So this is for the task 4, and yeah, as I said, the task 3 and for task 3 and 4, the only difference is data. What is the command? For task 3, the command is reading some info data, and for the task 4, we try to execute the reverse shell so that we can get the root privilege. So this is for the task 3 and the task 4. So for the TCP IP Attack Lab, so if you have the Wireshark on your virtual machine, I suggest you to use the Wireshark to get the sequence number of the packet. If you do not have the Wireshark, you can use what I presented using the TCP dump to get the sequence number. So using the Wireshark could be much more convenient, and I suggest you to do that. And also, as I mentioned, for the task for the task 2 uh, the launching the attack manually. For this task, we don't need. It is not mandatory. And if you have the Wireshark, you can do that. And if you don't have the Wireshark, you can just skip it.